Alright, so guys, welcome to your fourth video. In this video, we're going to be talking about proportional and non-proportional relationships. So this is chapter 1, lesson 4, proportional and non-proportional relationships. Our objective for today is to be able to identify proportional and non-proportional relationships, and our standards that we're going to be focusing on is 7th grade standard ratios and proportions standard number 2, standard number 2A, and standard number 2B. Let's go ahead and get started on our vocab, and then let's get into the lesson and see what happens. For our vocab today, we have 3 vocab words that we're going to be copying down. We have non-proportional, we have proportional, and equivalent ratios. So what the word non-proportional means is that we're having 2 things that don't have the exact same ratio. When we say ratio, we remind you that's just another word for fraction. So it says that the relationship between 2 ratios with a rate or a ratio that is not always the same. So what this means is that you're going to end up with a rate that ends up becoming a fraction, but the fractions aren't always the same. And proportional is when the relationship between the 2 fractions is always the same. So whenever you see that we're changing things, we always get the same number. That's proportional when it's the same. When it's not the same, that's not proportional. And then the equivalent ratios is when we're looking at a fraction that has the same value. So looking at 2 fractions that are exactly equal to each other, those are equivalent ratios. An example of that would be like if I said 2/4 is equal to 1/2. These are 2 equivalent ratios because they both have the same fraction value. 2 can simplify down into 1 and 4 can simplify down into 2, so they are equal and they're equivalent. Let's get started on our first example for today. In this example, we're talking about Andrew, and he's mowing lawns. So it says Andrew earns $18 per hour for mowing lawns. Is the amount of money that he earns proportional to the number of hours that he spends mowing? Explain. So what we have to do is we have to figure out whether or not a proportional relationship exists. Now remember, proportional relationships have the same value when you move from one to another. So what we could do is we can make a table. So what I'm going to do? Make a table. And on the top, I'm going to put money, and on the bottom, I'm going to put hours. And so what we're going to do is we're going to see how much money he earns in each amount of hours that he's working. So if Andrew made $18, he worked 1 hour. If Andrew made $36, he worked 2 hours. And if Andrew made $54, he worked 3 hours. And if he made $72, he worked 4 hours. And if he made $90, he worked 5 hours. So our job is to see if this is a proportional relationship. So what we would do is we would take the amount he made and we divide it by the amount of hours he works, and we see if it's proportional by seeing if it's always the same. So we make ratios with these. So we would check 18 over 1. Well, 18 divided by 1 is 18. 36 over 2. And 36 divided by 2 is 18. 54 over 3, and we get 18. We could even do 72 over 4, and we get 18. And if we did 90 over 5, we'll still get 18. So every time that we look at our fraction of our numerator divided by our denominator, we always end up with the same answer. Since we end up with the same answer, this would be a proportional relationship. So is it proportional to the number of hours he spends mowing? Yes. And that's because all the ratios have 18. They can all be simplified to 18. So in a proportional relationship, what we want to do is we want to take our numerator, divide it by our denominator, and see if we're always getting the same number. If we do get the same number, that's proportional. If we don't get the same number, that's non-proportional. Let's try another problem. In example 2, we're going to talk about Anna. Anna walks 6 miles per day. Is the number of miles proportional to the number of days that she walks? So we're talking about miles and days. Those are two things that we're going to use in our ratio. And we need to figure out whether or not a proportional relationship exists. Now, reminder, from our previous example, we found out that proportional relationship is when we can take the top numerator, divide by the denominator, and we always get the same answer. So let's go ahead and write a table just like we did the previous one. So we have miles and days, and then if Anna walks 6 miles, then that means 1 day has passed. And we go 6 more. If Anna walked 12 miles, then that means 2 days have passed. 18 miles, that means 3 days have passed. 24 miles, that means 4 days have passed. And 30 miles means 5 days have passed. So our job now is to see whether or not a proportional relationship exists. So what we're going to do is we're going to take our numerator, divide it by the denominator, and see if it does work. 6 divided by 1, that's 6. 12 divided by 2, that's 6. 18 divided by 3, that's 6. 24 divided by 4, that's 6. And 30 divided by 5. That's 6. So if we take our numerator divided by our denominator, we're always going to end up with the answer of 6. Since all we get is the same answer of 6, this means this is a proportional relationship. So what we're going to do is say, yes, this is proportional because it says explain. And that's because y divided by x will always equal 6. So what I did was I wrote that yes, this is proportional because when we take the y value divided by the x value, we always get 6. And in case you guys didn't know, when looking at a table, the x value is always days, and distance is usually your y value. So when I take my y value divided by my x value, I always get the same answer. And since I'm always getting the same answer, that's a proportional relationship. Let's try a few more. In example 3, we're looking at a real-life example. A lot of times this happens whenever you order tickets, you end up with a processing fee. So here's an example. It says Uptown Tickets charges $7 per baseball game ticket plus a $3 processing fee per order. So every order that you do, you have to pay $3 extra just to get your tickets. Is the cost of an order proportional to the number of tickets ordered, and explain? So here we already have our table set up for us. If we bought 1 ticket, then that means we have to pay $7 plus the additional $3, which means that we're paying a total of $10. If we buy 2 tickets, we're paying $7 twice. That's $14, but we still have to pay that $3 processing fee. That's what moves us to $17. If we buy 3 tickets, that's 3 times 7, because 3 tickets times $7, 21. But it's 24, and that's because we still have to add that $3 processing fee. And if we buy 4 tickets, that's 4 times 7, that's 28, and we still have to pay our $3 processing fee, and that's what brings us to 31. So if our price is $31, $24, $17, and $10, we have to say, is this proportional or not proportional? Proportional means that we're always getting the same amount for our buck. So let's check. At 10 divided by 1, we get 10. So right now, this is the number that we're looking for every time we take the numerator, divide by the denominator to see if we're always getting the same answer. At 17 divided by 2, we get 8.5. So right now, I can tell you that this is not the same. We keep going. We have 24 divided by 3. Okay, that's 8. So right now we can tell that the price of a ticket, or the price that you're paying for every ticket, is actually going down the more tickets you buy. So if you only bought 1 ticket, you're spending a lot of money. But the more tickets you buy, it's actually getting closer to the amount of $7. So this is not a proportional relationship. And I could do the last one, 31 divided by 4, but I'm not going to go ahead and do that. That's because we're pretty much right there. I believe that's 7.752. So we can tell this is not proportional because none of these numbers are the same when we take the numerator divided by the denominator. So this is not proportional. And that's because it's not the same ratio. In order to be proportional, we have to have a constant ratio. Constant ratio means we're always having the same ratio. So we don't have a constant ratio, so this is what makes us not proportional. Non-proportional relationships do not have a constant ratio. Let's go on to example number 4 and see what happens. In this example, we're looking at another real-life example, something that could be with the cleaning service. So it says the cleaning service charges $45 for the first hour and $30 for each additional hour. Our job is to figure out if the fee is proportional to the number of hours worked. It says that we need to make a table of values to explain our reasoning. So what we're going to do is we're going to make a table, and then we're going to check our table to see if it's proportional. If it's proportional, we'll end up with the same value when we take the numerator divided by the denominator. And if it's not proportional, we'll end up with different numbers each time. Now I got a calculator set aside ready to go just in case I need it. So, make a table here. I'm going to draw a line in between my table. And let's say this is how much money we earn, and this is how many hours that they work. Now, let's start with 1 hour. If we only work for 1 hour as this cleaning company, if we only have 1 hour of work, then it's $45 because it's $45 for the first hour. So we're going to put $45 here. Now, for every hour after 1, it's $30 more. So if I worked 2 hours, well, $30 more and 45 is $75. If I worked 3 hours, $30 more and 75 is $105. If I worked 4 hours, $30 more than 105 is 135. And I'm going to go with 2 more. 5 hours, $30 more, 165. And then if they worked 6 hours, you get $195. So this is my table based on the information of the question here. What we do is we look at it and we say, okay, well, it's 45 for the first hour. So for 1 hour, it's $45. And a lot of companies do this. They charge you more for that first hour. After that, they charge you a standard rate. So if you work 2 hours, it's $30 more, 3 hours, $30 more. Our job is to see, is this proportional? Well, it's always the same number. They're always charging $30 for every hour, but we actually have to see, is this a proportional relationship? So what we're going to do is take the numerator, divide it by the denominator, and see if it's proportional. So I got my calculator ready just in case. 45 divided by 1 equals 45. 75 divided by 2, I'm going to type that in, 75 divided by 2 equals 37.5. 105 divided by 3 equals 35. 165 divided by 5 equals 33. And I'm going to write the 195 here. 195 divided by 6 equals 32.50. So looking at these numbers, 45, 37.5, 35, 33, 32.50, we can determine that this is not a proportional relationship. In order to be proportional, the number that when we take the numerator divided by the denominator has to be the same. So we don't have the same number, non-proportional relationship. So what you would do is see how it says explain. We're going to write that it's not proportional because ratios, which is another word for fraction, so what you would do is you'd write that it's not proportional because the ratios are not the same. Now, if you don't have this other piece of work, then I'd be like, well, how do you know? So you need to make sure you have your table and the information that shows that you divided them to see that they're not the same. So this entire answer relies on the table and everything from here. If you just wrote this last sentence, you're not going to get full credit if you try to do that on like a test or something like that. You need to show me how you know that the answer is correct. Let's go ahead and move on. What we have for example 5 is we have a recipe. What we want to do is we want to see if a recipe is proportional, because if it's proportional, then that means we could take this exact same recipe and make it bigger, so that way we could give more drinks out to more people and stuff like that. So we're going to go ahead and test this recipe and see if it's proportional. It says you can use a recipe shown to make fruit punch. Is the amount of sugar proportional to the amount of mix used? And our job is to explain that. So what we're going to do is make a table. So we're going to compare sugar to mix. So sugar is going to be on the top, mix is going to be on the bottom. If I have half a cup, I'm going to need 1 bag of mix. If I have, half and a half make 1 whole. If I have 1 cup, I'm going to make 2 bags of mix, or I'm going to need 2 bags of mix. So let me make this a little nicer here. If I have 1 cup, I can make 2 bags. If I have 1.5 cups, I need 3 bags. If I have 2 cups, I can make 4 bags. And I could do 2.5 over here, and I'll need 5 bags of mix. So our job is to see, is this proportional? So I'm going to change 1/2 to its decimal, just so everybody knows. 1/2 is equal to 0.5. So what I'm really doing is I'm taking 0.5 and dividing it by 1. Well, 0.5 divided by 1 is 0.5. I'm taking 1 and dividing it by 2. 1 divided by 2. 0.5. So right now, after doing 2 pieces, I could say that, yeah, this is probably proportional. You always want to test all your values, though, because sometimes at the end, maybe somewhere in the middle, it might not be proportional. So always test every single fraction to make sure it is proportional. This is 1 and a 0.5. So we have 1.5 over 3. 1.5 divided by 3, 0.5. We have 2 divided by 4. 2 divided by 4 is 0.5. And that's 2 and a 0.5. So that's 2.5 divided by 5 equals 0.5. So in this case, our recipe is proportional, because every time we take the amount of sugar and we add a half, and every time we add a whole on the bottom, we're always ending up with the same number when we take the numerator divided by the denominator. So you would say that, yes, this is proportional. And the reason why is we could say that our ratios are the same. So proportional relationship is where the ratios or the relationship always has the same number when we take the numerator divided by the denominator. And again, in order to have the correct answer, you still need to have the table, you need to have your fractions and decimals, and then you need to explain how you know whether or not it is proportional or not proportional. By saying they have the same and showing me that they are the same, that's how you know you got the right answer. Let's go ahead and do a couple more and then we're done for today. We're on to our last 2 examples. In this example, what we're doing is we're looking at 2 different tables. We have Martin and we have Gabriel. It says the tables represent the number of pages Martin and Gabriel read over time. Which situation represents a proportional relationship between the time spent reading and the number of pages read? Our job is to explain that. So what they want us to do is they don't want us to just pick which one is the answer, but they want us to show how we know that one is the answer. And this is what they mean by explain. We cannot just pick one. We have to say how we know that's the right answer. So we have to show our work from start to finish. So what we're going to do is we're going to go ahead and take our fractions of each one of these. We're going to make them fractions. And then we're going to compare and see which one is constant. A constant rate is proportional. A non-constant rate is non-proportional. So I'm going to take 2 and divide it by 5. I have my calculator right here. 2 divided by 5, 0.4. 4 divided by 10, 0.4. 6 divided by 15. Oh, I need to show my work. 6 divided by 15, 0.4. So right now I can look at this and I can say, okay, well Martin is reading at a proportional relationship because we always get 0.4 as the answer. So we would say, yes, this is proportional. Because it's always the same. So my explanation is actually happening right here. The fact that I can see the proportional relationship happening. When we're looking at Gabriel, we do the same thing. 3 divided by 5, that equals 0.6. 4 divided by 10, that equals 0.4. And 7 divided by 15, that equals 0.46 repeating. So if I'm looking at this, I would say, no, it's not proportional. And that's because it's not the same. So I'm able to explain not just how I know, but I'm actually showing the difference of the other one. And that's one of the things that you have to get in the habit of, is showing how you know the difference between both of them. So that's what it means by explain. Show your work and explain how you know that you're right and how you know you're wrong. Yes, it's always the same. No, it's not always the same. Proportional relationships. Let's do one more and you guys are done for a day. You guys are doing awesome. So we're on our final example. Great job for getting here. Which situation represents a proportional relationship between the time spent typing and the number of words typed and explained? So in this problem, we're comparing two different tables. We have to determine which one is proportional and explain how we know that that's the proportional one and the other one's not. So what we're going to do is we're going to actually solve both of these the same way we've solved all the previous problems, and we're going to see which one is and which one is not proportional. So I'm going to go ahead and grab my calculator, get ready for the problem just in case. So we have 20 divided by 30. 20 divided by 30 is 0.66, and it's repeating, so I'm going to put a line above that. 40 divided by 60 is 0.66. And again, that looks similar. It looks the same, so we're going to try one last one. 60 divided by 90. And we get 0.66. So right now, the words that Emilio typed is proportional. He typed 20 words in 30 seconds, 40 words in 60 seconds, 60 words in 90 seconds, which means that his rate is about 20 words in 30 seconds, consistently at 2 words every 3 seconds. So yes, this is proportional. And you can say the rates are always the same. So again, proportional means always the same, where non-proportional means not always the same. Now, let's check this one here. I'm going to assume that this one is proportional because the other one wasn't. I had to clip this because I got an interruption, but let's just make sure that this is not proportional. So, we have 25 over 30. And that equals 0.83, and the 3 is repeating, so I'm going to put the little bar above the 3. That means only the 3 is repeating. We have 60 divided by 60, which equals 1. And we have 80 divided by 90. 80 divided by 90 equals 0.88, and the 8s keep repeating. So again, yeah, we're right. This is not proportional because these are not the same, where this one is proportional because these are the same. So I'm going to go ahead and write that this is not proportional. And that's because they're not the same. So in this lesson, you learned how to find proportional and non-proportional relationships. Proportional relationships have the same ratio whenever you take the numerator divided by the denominator in your tables, where a non-proportional relationship does not have the same ratio. So if you like this video, go ahead and click that like button, hit subscribe, and I'll see you tomorrow.